Hello, and welcome to this first video lecture from section 2.2 talking about separable equations. So in this video, we're basically just going to go into what are separable equations and how does one determine if an equation is separable. In later videos, we'll talk about how you go about solving it and what you do, what these equations can do for you. But this, we're just going to go through identifying them. This will be a shorter video to talk about that, and I'll move on to solutions in later videos. So let's go ahead and jump on into that. So in this section, we're dealing with general or differential equations, first order equations that look like are of the form dy dx equals f of xy. So we have just some arbitrary function on the right hand side, could be linear, nonlinear, I don't care what it is, there's just some function over there, we have an equation of that form. Now if we look at this, we can see we can also write it in this kind of form. So we rearrange the terms a little bit, and we can write this as a function m of x and y plus n of x and y dy dx equals 0. Now there's an easy and obvious way to do this. You can just set m of x and y to be negative f and n to be 1. That works. It does it. It satisfies those conditions. I've rewritten it in that form. However, there might be better ways to do that. For instance, if f has a fraction, I can clear the denominator and move that over to n, that sort of thing. Now, if an equation is separable, that means in some sense x and y, the independent and dependent variables, are somehow isolated from each other in a certain specific way, but they're isolated. So what it means for it to be separable, so an equation is separable if I can do this transformation in such a way that m only depends on x and n only depends on y. So if I can write my equation in a way where the m function only depends on x and the n function only depends on y, then my equation is separable. So let's take a look at a couple examples of this and see how we can tell if an equation is separable or not. So example 1, dy dx equals 2xy. Now, in determining if things are separable or not, I am allowed to put things in the denominator. So this is easy to see. This actually is separable. So if I divide both sides by y and then move things around, I will see I get a 1 over y dy dx equals 2x, which turns into 2x minus 1 over y dy dx equals 0. So this is separable. And it turns out that's usually a really good thing in terms of being able to solve the equation. So let's check out a second example here. So our second example is 3xy plus 2x squared. And it's kind of hard to see when an equation is not separable, but you can see this one is not going to end up being separable. If it's separable, I basically have to be able to take the right-hand side here and pull everything that's in y out to the front so I can divide by it. Now in this case, I can't do that because only one term has a y, namely this term has a y in it, but this term does not, which means I can't factor out a y from every term. So since you can't do that, it turns out this equation is not separable. It is, however, first order linear, so it's not hard to solve, but it's not separable. So another thing you'll see with these separable equations is, right, we had our equation that we could write in the form m of x plus n of y dy dx equals 0. You can also have this written, the book does this, so I want to make a point about it here. It's not necessarily important that you know that you can do this, but you can. you can write this in a differential form as m of x dx plus n of y dy equals 0 by, in some sense, clearing the dx from the denominator. You will see this written. It's not necessarily that important, but I want to make a point about it. It's also somewhat indicative of how we're going to be solving the equations in the next video. So that's really the only point for this video, is figuring out how you can tell if an equation is separable. And it's by saying, can you write it in this form, m of x plus n of y dy dx equals 0. So your sample problems here are going to be 2 examples of seeing if an equation is separable or not, and then if it is separable, writing it in the proper form. So I'll put those up there for you now. All right, so there's your question for the worksheet. Also, as a note, don't get fooled by changes of letters, right? dy dx, dp dt, the equations are all equivalent. I'm just changing the names of the variables. Doesn't matter what they're called, as long as they're set up in the same way, the equation still works the same way. So take a look at that, give me those 2 answers on the worksheet, and bring that into class tomorrow. Thanks for watching, and I will see you in the next video.